4, part 4. This is the last type of problems we're going to do. Tomorrow we have EOC review, and then on Friday and Monday we will have test review. On Tuesday we'll have our test. What else do we have on Friday? Folder check. Folder check is Friday, guys. Okay, let's go ahead and get started. So the 2 types of problems today. This one is going to be very different. This is the first one that's going to be set up completely different than any other problem that you've seen. It's not hard. It only has to solve for one variable every time, and it's set up the same way every time. So that makes it easy, but it's different, so it makes it a little more challenging. So starting off with, it says a fashion designer makes and sells hats. The material for each hat costs $5.50. So every time they make a hat, they have to pay $5.50. The hat sells for $12.50. That means $12.50 comes into them every time they sell one. The designer spends $1,400 on advertising, meaning that money goes out. They have to pay that out. So we got to think about money going out versus money coming in. Okay, that's what we're dealing with. Either we're talking about expenses or we're going to be dealing with profits, money that's coming into us, that's coming in on top of stuff. So it says, how many hats must the designer sell to break even? To break even. So this is going to be a little different than what we've been dealing with before. So X, what are we looking for? We're looking for the number of hats that you have to sell to break even. So X is going to be the number of hats. Whatever the item is, when you're doing a break-even problem, you're doing the number of whatever item you're talking about. Number of coloring books, number of magazines that they're selling, number of shirts that they're trying to create. Whatever it is they're trying to break even on, that's the number of that you put there. The Y is always the same. Y is written as expense slash income. I had to look at the C right now. Okay, expense slash income. Guys, that's the money going out and the money coming in. And the way you write these equations is based on that expense or income. They're both written as Y equals every time. It makes it really easy to set these problems up. They're both going to be Y equals. It's the money going out, the expenses, or the money coming in. So let's start with the money going out. How much do they spend every single time they make a hat? $5.50. 5.50. How many hats will they be making? X is exactly right. We wrote down the number of hats is X. I love the way you said that, like maybe. So it is X. That is 100% correct. What other money is going out? What else do they spend, guys? Advertising. How much? What was it? $1,400. So you got to add the $1,400 to that. That is all the money that's going out. Guys, this is the expense. This is money going out. The other equation is going to be for the income or the money coming in. So how do we tell how much money's coming in? What are they getting paid every time they make a hat? Or, well, not make one. Every time they sell a hat. Sorry. $12.50. So it's going to be 12.50. What? How many hats are there? X. Good. A little more confidence on that one. Now, in order for you to break even, the money going out has to equal the money going in. So these two amounts need to be set equal to each other. But guys, do y'all see it's so easy because they're both Y equals? So you're just going to take and put a box around. It does not matter which one you put a box around because they're both Y equals. I'll put it around this one. And I'm going to plug it in where the Y is in this problem so that I can set them equal to each other. I'm going to set 12.50x. That's what I'm plugging in where the Y is. All I'm doing, guys, is putting it right there. And I'm putting the rest of the equation, which is equals 5.50x plus 1,400. Do y'all see that every time it's going to be that same thing where all you do is set them equal to each other? You're canceling out the Y. That's what you do every time on these. Every time. Okay. From there, we are going to minus 5.50x minus 5.50x. Got your calculators. Do 12.50x minus 5.50x. What's that give you? 7? Is that what y'all said? 7? 7x equals 1400. There you go. Divide both sides by 7. And x equals 200. Now listen, this is a unique problem. That is the only variable we need. We only need to know that we have 200 hats up here. We don't need to know expense and income. It doesn't ask about that. It says how many hats must the designer sell to break even. So when I'm doing these problems, this is going to count for 1 point. This is 1 point. This is 1 point. This is 1 point. Because there's only one equation, this is going to be worth 2 points, and the word answer is still going to be worth 2 points. So what is the answer to the question? The answer is that, what is it? I was looking to see, the designer must sell. I was trying to see if they said he or she. The designer, that's how you spell it? Yes. Must sell 200 hats to break even. Now, guys, this is obviously a very simplified version of this, okay? You're going to have to pay for, like, employees' insurance, and you're going to have to pay for the lights to be on, and you're going to have to pay for all these things. And they've broken it down and taken all that and kind of based it on the hats individually. But that's going to change depending on how many you do, etc. But this is a basic way to see, especially if you're doing a smaller business like an at-home business, how this might be where you need to know, if I get to this point, then I am breaking even. I'm not losing any money. After this point, what will you be making? What's it called when you make money on something instead of lose money? It is income, but it's also a profit. That is correct. Okay, you're earning the income no matter what. Even if you're doing it before, it's still income. The money coming in even before you break even is still income. But that minute you break even, everything beyond that is profit. That's what it's called. Okay, guys. Anybody have any questions before we go to the next one? Do you see these are a little bit shorter? There's a little bit less to them. These are the same every time, but you just have to know the format. If you learn the format, these will be the first ones you do on the test, and I'll explain what I mean on that in a minute. Okay, here we go. Oh, anybody still writing? I'm sorry, I didn't ask. Bless you. Okay, here we go. Next one. A puzzle expert wrote a new Sudoku puzzle book. His initial costs are $864. Binding and packaging each book cost 80 cents. The price of each book is $2. How many copies must be sold to break even? So guys, anytime you see this, break even, you're looking for that basic concept. So you're starting off with X equals the number of, what is it? Number of puzzle books? And then Y, what do we write down for Y? Expense slash income. Bless you. I can't tell if people are coughing or something. Bless you. Go. Okay, guys. Each one of your equations starts with what variable every time when you see this kind of problem? Y. Y equals Y equals. Every time it's Y equals Y equals. Okay. First, we're going to start with the money going out. How much do they spend to create or put together each book? The 0.80 or 0.80, some of y'all like that 0 in front. 0.80, and how many of them? X. You can say it. Y'all don't want to say that X. Okay. What other expense, money going out, what else are they paying in this process of creating them? Say it. Guys, how much money, what else are they spending money on in the beginning? Read it. Read the sentence. That's that $864. They had to create them to set them up in the beginning. They had to pay that money out in order to get this set up. Got a few of y'all like whispering it. Come on. Come on. Okay, what about money coming in? How much are they making on every book? How much do they get every time they make a book? $2. Sorry, every time they sell a book. So it'd be 2 and how many? X. We put a box around it. We plug it right into that Y that's right there. Guys, basically you're setting the X parts together. That's all we're doing. The substitution just makes it easier if you show it like that so people know what to put where. The 2x is going to go in front. The point 80x plus 864 goes on the back. Does it matter which one goes on which side? No. You can substitute either way. It's not going to make any difference which way you substitute that in. We're going to move all the x's to one side by subtracting 0.80x, subtracting 0.80x. Okay, guys, it's going to require your calculator. What is 2 minus 0.8? 1.2x, is that right? 1.2x equals 864. You then divide both sides by 1.2. And x equals, what's that give you? Even? Okay, 720. Again, you don't have another equation to plug it back into. It doesn't ask about the income or the expense. If it did, you could plug it back in and find that out, but it doesn't ask that. All it asks for is how many copies to break even. That is 720. You'll take that. That's going to be 720 puzzle books. Puzzle books. There you go. Yes, ma'am. You did 0.08. No, instead of 0.8. Try it again. I know what you did just because I've typed that before. Not that specific number, but I've typed the decimal that way. Did you get it that time? Yeah, it's just you put the 0 after it instead of before if you were typing the 0 in there. Like, you switched them. Anybody else? Okay. Sentence. What is it? Who is it? Doesn't give a name or anything. The puzzle expert. Must sell 720 copies. Now, guys, if all you do is write that he must sell 720 copies and put a period, I'm going to take points off. It's what does he have to sell the 720 copies to do? To break even. That's the key. To break even. What does the 720 copies mean? It means that he breaks even. So you have to put that down. That's what they're actually asking you for. Okay, for the break-even problems, does anybody have any questions before we do our last type of problem? The last type of problem is going to be dealing with, like, if you're going down a river and you're going with the current, you're going to go faster, right? If you try to go up the current, you're going to go what? Slower. And we're going to do some problems that deal with that on the next thing. That's the next type of problem we do. Anything before we leave this one? Nothing yet? No? Okay, here we go. So, the last thing we're going to do, last type of problem out of all of them, guys, because this is our last thing, is going to be turning the problems that have to do with wind speed, airspeed, all this kind of stuff, into problems that don't make you go, what? Guys, this is very easy. It either makes you go faster and you add it, or it makes it go slower and you subtract it. It's that simple. Okay? So here we go. We got a traveler, what's that word? Traveler, flying from Charlotte to Los Angeles in a plane with a ground speed of 550 miles per hour. At the same time, another traveler flies from Los Angeles to Charlotte in a plane with a ground speed of 495. Guys, why would you go faster in one direction than you would in the other? Huh? I couldn't hear you. It's going with the wind or it's going against the wind. That's exactly right. When you fly out, you're usually going one way. If you're flying back, it's usually the other. Depends on the wind at the time, but it's usually going to fight against it. So, when you see this, the airspeed of each plane is the same. Okay, so the airspeed's the same. It says, what is the airspeed? What is the wind speed? You're asking, it tells you what the, guys, it even tells you what the variables are. X equals, what's the first thing they're looking for? They're looking for the airspeed. So X is going to be your airspeed. And Y, look right here, it tells you right here what it is. The other thing they're looking for is the wind speed. So as they're flying through the air, they're flying at the same speed. The plane's like mileage is set at the same thing. They're set to fly at the same speed. But the air is either helping it or the air is either hurting it. So when you think about it, you're either taking that airspeed and adding y to it to make it go faster, or you're taking that airspeed and you are subtracting y from it and it makes it go slower. For the first one, when they're going faster, how fast are they going? Guys, look at the two. Which one's faster? That's going to be the adding one. Okay? That's going to be the what? The first one, the 550. Perfect. And the second one, when they go slower at 495, that's when the wind is making it slow down. Guys, the formula is the same every time. And the nice thing about these are some of the simplest ones to solve because they already do what? Eliminate. What is x plus x though? Please don't get that wrong. 2x equals 1,045. Check my math, guys. Yep. Okay. Divide by 2, divide by 2. X equals 5, 2. Oh, this is going to be a decimal, isn't it? Yeah. 522.5. Okay. 522.5. Okay, that's x. X. What are you going to do with that? Plug it back in. I would plug it to the one without the subtraction in it. Make your life easy. Hold on, I'm going to put this over here. This is the x, so it's 522.5. And guys, what are we talking about? What's the unit? That's the airspeed. But what do we put it as far as units? Miles per hour. Which miles per hour is the way they have it written. You could do mph is also miles per hour. I would take that too. It's the same representation. Okay, plug it back in. You get 522.5. We're plugging in where the x is in this equation. Plus y equals 550 minus 522.5, and y equals 27.5. No, can't be negative. The wind's not going to go negative. The slowest wind can go as 0. Check the math on it again. I just want to make sure. Should be 27.5 miles per hour. Is that it? Okay. You got to do 550 minus the 522.5. We good? Everybody good? Okay. So here we go. Sentence-wise. Okay. It asks us, what is the airspeed? What is the wind speed? So the airspeed is 522.5 miles per hour, and the wind speed is 27.5 miles per hour. It's a pretty hefty wind if you're flying. It's not terrible, but it would be, you'd be jostled around a little bit. Concerns, questions, anything about it? Because I'm going to get you to see if you can set up the second one based on that. Okay. For the next problem, what I would like you to do, I would like you to try to write the two equations and write define the variables. So define both variables and then write the two equations for the next one. I want to see if you can set that up. Don't try to solve it yet. Wait on us. Don't solve it and do it wrong, guys. Just wait. Just do that first part. Define the variables, set up the two equations. Try that now. It's almost identical. It's the same process on these every time. So try setting that up. Okay, let's see if we got this set up right. Let me see how I do it. So you row upstream, 2 miles per hour, you stay just downstream. What is your rowing speed? It's still water with speed and current. So X is going to be your rowing speed. Whatever comes first, guys. Whatever they're asking for first, first variable. Second variable, speed of the currents. Okay, so it'd be the rowing speed plus the current to make you go faster. And then, oh no, upstream is against. So the first one's actually minus, isn't it? The one that makes you go slower. And then the second one would be downstream, that's with the current, so that'd be the plus. So that'd be the one that has that. Okay, take a look, guys. See if that's what you've got. Ask me a question if you have one. The key to this is that upstream goes against it. It's going to be taking away your speed. If you're rowing upstream, if you've ever done like where people are tubing or something, you try to go upstream, you have to work really hard to row against the current if you're canoeing up or kayaking up or whatever you're doing. It is not an easy feat. It's not like impossible on some of these rivers because they're slow, but if you get on any of them that have a serious current, you're going to be hitting something that's going to make your life a little hard. So this is going upstream, so it's going to slow it down. That gets to 2. How can you know to put the minus with it? Because guys, look at it. It's the slower speed. The one that goes faster is going to need the plus with it. So far, are we okay? Questions? Okay. That cancels out immediately. We get the 2x is equal to 7, divide by 2, divide by 2, and x equals, 3.5. It's real life stuff, guys. You're not going to leave your real life stuff as 7 over 2. It would be 3.5 miles per hour. Hold on 1 second. And, sorry, took my train of thought when I did that. Hold on. So it'd be 3.5 miles per hour. You plug that back in. Take and plug that back in. It's going to plug into this. Guys, why would I plug it into the bottom one, not the top one? Why would I plug it in the bottom one? Because it's addition. No subtraction to deal with. Mainly just so I don't mess up the negative sign. So it's going to be 3.5 plus y equals 5 minus that 3.5. Do you get the same answer if you plug it back into either one? Yes. Just got to deal with the negative sign. And it makes it 1.5. I don't have any idea if that's fast or slow for a current. I'll have to look that up. Water moves, I mean, it's very strong. Water is very, very strong, even going slow. Yes?
So, I did, like, the top, and the plus, and the bottom, and the minus.
Did you put the numbers with the right ones, though? That's perfectly okay. As long, right, but you only get it right if you put the numbers with the correct sign. Did you do the x plus 5, x plus y equals 5 on the top?
I did x plus 5.
You won't get the same answer. Yeah, you won't get the same answer when you plug it back in. Did you plug it back in and get the other one? You won't get the same answer. It gives you a negative.
Yeah, I got a negative.
That's why it's messed up. That's why. So it's always going to give you a negative for the second one if you do that wrong to begin with. Thank you for bringing that up because it really does matter. Okay? Anybody else? Any questions, concerns, anything else? Yeah, if you set them up backwards, guys, it's going to give you a negative for that second one. It's going to mess you up. Okay. Take this then and put this in your folders. Let me go ahead and get this paused. We've got our notes